Welcome. Today, we'd like to present updated comparison of 8 different resilient channels with and without isolators. Perhaps the best place to start is with the history of resilient channels. In the mid-60s, USG introduced Resilient Channel, later renamed to RC Deluxe. After USG's patent expired in the mid-80s, the want-to-be and copycat resilient channels appeared everywhere. The acoustical performance between brands was checkered at best. Most brands of resilient channel were not tested for acoustics nor for fire, rather simply asserted equality to RC-1 Deluxe based upon shape or contours. These unreliable and unpredictable noise control solutions remains basically unchanged. In 2016, PAC International developed, patented, and tested the RC-1 Boost. Today, we are honored to reintroduce the RC-1 Boost acoustical test results when added to 8 different resilient channels. The RC-1 Boost is a viscoelastic isolator combined with a purpose-built, custom-made screw, which helps commercial-grade resilient channels equal or exceed RC Deluxe acoustically and in fire. PAC International tested 8 different models of common resilient channel to discover the performance potential for each specific model when combined with Boost. Today, we're focused on presenting the most cost-effective system and assembly laboratory test results. Please note RC-1 Boost adds 1/4 inch to the traditional RC-1 half-inch offset, making a combined total of a 3/4 inch offset from face of framing to back of gypsum board when the RC-1 Boost is used with traditional RC-1, thereby reducing the potential for short circuiting. The specific channels tested: Semco RC-1, Clark Dietrich RC-1 Pro and RC Deluxe, Marinoware RC-1 and RC-1 Max, Philips Manufacturing RC-1 True 25 and RC XL, Scafco Serenity RC Plus. These resilient channels are only a sampling of the various resilient channels available in the U.S. today. The tested floor ceiling assembly. The components consisted of CARES hardwood finish floor, 12 millimeters, floating on E-Core QT 4002, 2 millimeter recycled rubber mat, floating on lightweight gypsum concrete, 3/4 inch thick, poured directly, no mat, on OSB subfloor, 3/4 inch, T&G, glued and screwed on open web timber truss, 18-inch deep, 24 on center, fiberglass insulation, 3.5 inch thick, craft face, secured to the OSB, resilient channel, 16-inch on center with boost isolators, 24 on center, gypsum board, 5/8 Fire Code C, single layer, in compliance with UL fire resistive design assembly requirements. Here's a drawing of the components, and I'd like to bring your attention to the resilient channel near the bottom, which is installed perpendicular to the truss framing member, and the RC-1 Boost occurs at each truss and RC channel intersection. Laboratory test results. 6 of the 7 resilient channels tested with Boost test results were STC 61, IIC 57, HIIC 64. One of the 7 resilient channels tested with boost test results was STC 61, IIC 56, HIIC 69. Note only one IIC point deviation over 7 different models. Here's a graph plotted at 1/3 octaves of the 7 RC1s with RC1 boost. The orange line represents Dietrich RC1, the yellow line Marine Aware RC1, the dark blue Scafco Serenity RC Plus, the medium blue Philips RC1 True 25, the silver line Philips RC1 Max, the green line Semco RC1, and last, the light blue line Merino Wear RC Max. 6 of the 7 had an IIC of 57 and 1 an IIC of 56 as reported prior. RC1 with and without boost. The open web timber truss as shown above, the test results are the best you can ever expect in light of the fact the installation was in a laboratory condition and tightly managed. The Philips RC1 True 25 without boost with 1 layer of 5/8 gypsum board, the test results were STC 58, IIC 50, HIIC 65. These laboratory test results is a typical of low-cost RC1 at or below code. Using the same RC1 True 25 with boost, 1 layer of gypsum board, the test results were STC 60, IIC 57, HIIC 66. These results are typical of the RC1 plus boost. The delta with boost was plus 2 STC and plus 7 IIC. RC Deluxe versus RC1 plus boost. 6 commercial grade RC1 with boost on the same test assembly as above. 1 layer of gypsum board. Test results were STC 60, IIC 57, HIIC 64. RC1 Deluxe without boost on the same test assembly as above required 1 additional layer of gypsum board for a total of 2 layers of gypsum board to equal the boost assembly above. STC 61, IIC 57, HIIC 67. Of the 6 tested RC1 with boost compared to the RC1 Deluxe with 2 layers of gypsum board, the delta was minus 1 STC, minus 0 OITC, and minus 3 HIIC. The saving with boost over the RC1 Deluxe is the cost of the extra layer of gypsum board, labor and material installed, approximately $1 per square foot. Laboratory limits. It was suggested the consistency in the boost test results may have been caused by the laboratory limits. To confirm the laboratory limits, we tested a new PAC International resilient sound isolation clip, specifically RSIC-SI-X, in the same test chamber on open web truss floor ceiling with 2 layers of 5/8 fire code C gypsum board. The test result was an STC 70, IIC 70, HIIC 79. This test result suggests we have not hit the laboratory limits. How did we achieve consistent results? We set in place a detailed list of variables which would impact the test results. We discussed each detail with every build team member, then focus on the details of the installation. The same details all of you know and focus on for your RC-1 projects. The foregoing was true for all RC-1 tested. To ensure the test report accuracy, we conducted baseline tests before and after each test series to instill confidence in the test results and assure the test results were exceptionally accurate and consistent. All known variables were eliminated. Test conclusions. RC-1 with boost exceeded all RC-1 without boost by 5 to 7 IIC points. RC-1 with boost bested RC-1 Deluxe by the cost of one additional layer of gypsum board, approximately $1 a square foot. RC-1 with boost works with timber flooring, luxury vinyl tile, luxury vinyl plank, and ceramic tile. RC-1 Boost is environmentally friendly due to the reduced material and recyclability of all components. Although we have only discussed open web timber truss floor ceilings today, Boost works on any timber frame structure, on walls, floor ceilings, and roof ceilings. RC-1 Boost added to Resilient Channel. A large number of acoustical tests were performed on the same open web timber truss test assembly. The most impressive result was the test results achieved when RC Boost was added to a variety of resilient channels, which we have represented today. Actual components tested: 8 different RC-1s without boost, 7 different RC-1s with boost, 3 different rubber mat thicknesses, 3 different notch trowels, 2 different types of glues, 1 floating floor system, 3 different finished floors, equaling a total of 1,134 possible test combinations. Frankly, we did not test all combinations. The key variables were sorted out during testing process to reduce the number of tests to a reasonable and affordable test number. For example, ceramic tile is the most expensive to install and took the most laboratory test time waiting for the grouts and mortars to cure. So the number of ceramic tile tests were dramatically reduced to provide more chamber time for testing floating wood and luxury vinyl tile, which are very popular today. Closing statement. In light of the hundreds of tests conducted by PAC International in 2020 during the COVID-19 and the mountain of data collected from the tests, PAC International has plans to provide all the data which is relevant to the public as soon as possible via the PAC International LLC website. That site is www.pac-intl.com. The information presented today was seriously condensed due to the time limit. I hope this presentation was valuable to each of you. If you would like additional information on the testing and/or the test results, feel free to contact PAC International. Our website is www.pac-intl.com. Our toll-free number 866-774-2100. Thank you for your interest. I look forward to speaking with you.